Well, hiya.
You have some snoo in your hair. Doesn't he have snoo in his hair?
Yes.
Yes, it's
Not too much. What's new with you? Okay, that was my joke of the day. Okay, that was bad, huh? All right, that was on recording, so now you know me. So anyway, it said, I'm not sure what this joke means. I don't get it. This is lightning, this is not lightning. Do you guys get that?
The bug is lightning. I think it's trying to prove to you that either you're an idiot or not.
I don't know. I
The
don't
bug
get
is a
it.
lightning bug.
It's a lightning bug. Yeah, but that's kind of dumb. I don't know. So it says, when you look at a diagram, be careful not to assume too much from it. To assume something is accepted as true without fact or truth. You may assume that lines are straight. And if two lines intersect, that they intersect at one point. You may assume that all lines, you don't have to write all this down, assume that points at a line are collinear, that all points shown in a diagram are coplanar unless planes are drawn to show that they are not coplanar. Things that you may not assume. Now this is important. You can't assume that things are parallel unless they're marked parallel. So if you see a figure where you see some lines like this, and you go, what can you tell me about those lines? If they have arrows on the end. Okay? You cannot assume they are parallel unless they have little marks on them that look like this. Okay? That means parallel. So don't assume that. Likewise, when we get into the quadrilateral section, which is the very nice next section, what type of figure would that be? Can anyone tell me?
That's wrong.
Not a rhomb. Do you guys know what? We'll talk about this tomorrow, but that has two parallel sides, and that has a specific name. But if it's just like this without the parallel marks there, then you can't assume, well, that ends, right? But you can't assume that it's anything unless it, you know what I mean, okay? If these were connected, just because it looks like these sides are parallel, doesn't mean they're parallel. Likewise, if you see something like this, that crosses like this, what could you tell me about these two lines? They cross. That's all you can assume is that they intersect. You can't assume that this angle right here is 90 degrees unless they tell you it is 90 degrees. And if some things look congruent, like even if you see a triangle that looks kind of like, what's this? Even if you see a triangle, oh my goodness. That looks, I'm trying to find, if you see a triangle that looks like this, what can you tell me about that triangle?
It's a triangle.
It's a triangle. You can't assume that these two sides are congruent unless it's marked up like this, and now you can assume that those two sides are congruent. Okay? So be careful of your assumptions. All right? When I'm teaching, I would like the computers to be closed. Okay, thank you. Just because I know some of you want to get ahead, but I know you guys probably wouldn't do this, but some people are focused when they need to be. All right, so anyway, we're going to, I think since this is up here, where's the next page of this book? How do I get to the next page of this book? I'll go like this, go to the next page, I'll go to the next page. Okay, so here are right triangles, here are not right triangles. Is it right?
Not a triangle.
That's not even a triangle. Who can tell me what a right triangle is? And you should take notes. I don't have a note sheet for you because this is very basic. Someone new and interesting. Gaia.
a triangle with a 90-degree angle.
Yes, okay, that's what a triangle is. A right triangle, maybe you want to write these down, is a triangle. A triangle with a right angle or 90-degree angle. Okay? Why can't you have more than one 90-degree angle?
Triangles don't work that way.
Yeah, it wouldn't work, right? Because if you had more than one 90-degree angle, it'd be hard to make those two connect, right? All right? Yes? Okay. So a right triangle is a triangle with a 90-degree angle. Who can, wait, I'm going to give you a participation point. I can't give you Tootsie Pops every day, but I'll give you a participation point. Okay, who's going to tell me what an acute triangle is? Go ahead, Mary.
Triangle with a degree less than 90 degrees.
All angles are less than 90 degrees, okay? So not this one has two less than 90, but one that's equal to 90. So this is not, so an acute triangle, all angles less than 90 degrees, okay? Piece of cake, easy. Write it down. Write it down.
We already wrote it down.
No, that's an acute angle, not acute triangle. You wrote down acute angle, but didn't write down acute triangles. Last Friday we talked about angles, today we're talking about triangles. Okay? Next, we're going to talk about, what's next? Obtuse triangle. Obtuse triangle, look at what are obtuse triangles. Look at what are not obtuse triangles. Let's look at them in a new page. Let's make it big. Who can give me a definition of an obtuse triangle? Here. Universal. Aston.
It's a triangle with a one angle that's more than
Perfect.
90 degrees.
Okay. One angle that is more than 90 degrees. Again, I couldn't have two, right? Because then it wouldn't be able to connect. These things would go out forever. Okay. So you should write that down, or maybe you know it already. Obtuse triangle. One angle greater than 90 degrees. I know a lot of you know this already, but I don't know. It's not that obvious sometimes. Okay. Next thing they're going to talk about is, where's the next thing they're going to talk about? Scalene triangles. There's a scalene triangle. You can tell me what is a scalene triangle. And that's a word you probably have not heard before. Maybe some of you have. Go ahead there, Ryan.
A triangle without any equal sides or angle.
Good. We don't know about angles, but we'll just say no equal sides. Okay. So scalene triangle. No congruent sides. Or all sides. Just say this. All sides are different. All sides different lengths. Easy enough? Okay, a couple more and then we'll be done. I think you guys know what an equilateral triangle is, but let's talk about it anyway. Equilateral triangle. There we go. What's an equilateral triangle? Raise your hands. Go ahead there. Not looking at this. Go ahead, Grace.
Where all the sides are the same.
Good. All the sides are the same way. And in this picture it shows all the angles are the same, but really the definition is that all sides are the same. All sides congruent or the same length. And questions? No? Yes? Maybe? And then the last one is isosceles. How do you say that?
Isosceles.
Oh, that's right. I'm just kidding. I know this. Isosceles triangle is isosceles triangle is, let's look at the isosceles triangle. Who can tell me what is an isosceles triangle? Someone on the other side. What's wrong with this side? Okay. So I see your hand up there, Izzy, but I haven't picked on Dan. Have I picked on you yet, Danny? Go ahead.
It's a triangle where two of the sides are the same length.
Very good. A triangle with two sides congruent, okay? Isosceles triangle, can it have three sides congruent?
According to that, it can.
According to this, it can, right? So is an equilateral triangle an isosceles triangle?
Yes.
Yes. Is an isosceles triangle an equilateral triangle?
No.
Not necessarily. Could it be? Yes. Okay, but very good. Two or more sides. Nice. Two or more, or at least two sides. Two or more sides congruent. So isosceles triangle. And furthermore, when they, whoops, wrong tool. When they draw an isosceles triangle, I'm going to draw this one. Here's one. Okay. And I'm going to mark this up, and this, and mark, they call this bottom piece, that's called the base. Okay.
Regardless of its actual orientation.
Very good, that's what I was going to type. Gosh, you are in cover. They call this the vertex. The vertex. They call these things, this one and this one. We don't know that they're congruent, but I'm going to tell you. These two things are called the base angles. Okay? This and this. Those are called the base angles. Base angles. And I think that's how they say. And like Osi said, if I were
I'm
to
just guessing, man.
no, you're right. But if I take an isosceles triangle and I take it and I spin it, okay, even though this is over here on the left side, that's still called the base, right? And this is still the vertex, and these are still the base angles over here. So just because it's sideways, it's still an isosceles triangle. So, all right, we're good on that. Okay, did I teach you guys about the midpoint formula?
Yeah.
I think I did real briefly, but I didn't give you homework on it, and tonight, since tonight's is pretty short, I'm going to throw this in there, okay? So, midpoint formula. And I think I think a lot of you know this already from last year's class, whatever that may be. Midpoint formula is x1 plus x2, divided by 2, y1 plus y2 divided by 2. Okay, so if you have 2 points, if you have point A, which has coordinates x1, y1, and point B, which has coordinates x2, y2, then the way you find the midpoint between those 2 points is adding up the x's, take the average, adding up the y's, take the average, and finding the midpoint. For example, say I have an xy axis. Oh, that's bad. Why did that come out crooked? Oh, because I wasn't using the line tool. Let's use the line tool. Let's put arrows on the end. So here's a x, y axis, okay? And say that over here I have the point. I'll move. Oh, what did that do? Oh, I know what happened. I put arrows on the end of my lines. I don't want arrows on the end. So say I have this point over here. Say this is a point 2, 5. And we'll call this point B. And over here I'll have the point, let's call this -4, -1. And I'll call this point A. And I say find the midpoint. Could you do that? Okay. So all this says is I just add together my x's. So I'd have -4 plus 2. Whoops. -4 plus 2 divided by 2, comma, negative 1 plus 5 divided by 2. And if I do that, what's negative 4 plus 2? Negative 2 divided by 2? Negative 1. Negative 1 plus 5? 4 divided by 2? 2. So the midpoint would be at negative 1 up 2. Which looks about right, doesn't it? Negative 1 comma 2. I don't know, everything's not to scale very well. But if I were to connect those 2 points, I might get, let's not put arrows, let's make it red. Let's go like that. I did a bad job. But you get the idea, right? So that would be the midpoint. Now, one more type of problem that you're going to see based on the midpoint, which involves some algebra. Did I go too fast? Did anyone want to write that down? No? Okay. So one more type of problem you're going to see is like this. And then we'll be done, and then you can just do your homework. Okay? So here we go. One endpoint. Let's get rid of this thing. One endpoint of a line segment has coordinates negative 1, 2. Negative 2. The midpoint is 2, 4. And they'll say find the other endpoint. Okay. So with this one, you could do it graphically, but I would rather you do it algebraically, especially if you get really bad looking, ugly numbers. It's going to be hard. Like if you were going to the point 200, 763 or something, it would be hard to do with a graph. So you want to use that midpoint formula and set it up algebraically. So if you call this like x1, y1, and you call the other, so say this is point A. It doesn't really matter which you call. And we'll call B having coordinates x, we'll just call it x and y. We don't know what those points are, but we're trying to find them. You understand how that works? But we do know the midpoint. So using the midpoint formula, I know that negative 1 plus what? Plus x, not plus 2, okay, because that's the midpoint. Divided by 2 equals what? 2. Do you guys see where that comes from? Right? One endpoint plus the other endpoint divided by 2 equals the x coordinate. To solve that, who can tell me how I solve that? On this side of the room. I'm going to pick on you. Come on, tell me how to solve that. Tell me how to solve that. Rachel!
You multiply 2 on each
Very
side.
good. Okay, you multiply both sides by 2. So I'm going to multiply this side by 2. I'm going to multiply this side by 2, right? And I get, this goes away, that's why I do that. I get negative 1 plus x equals 4. And then I just do smaller algebra. Add 1, and I get x equals 5. So far, I know that this point is 5. Who can give me the equation to find, who can give me the equation to find y? Go ahead. Okay, Karen.
Negative 2 plus y.
Negative 2 plus y
Divided by 2
divided by 2
equals 4.
equals 4. Okay? And who wants to tell me how to solve that? Go ahead. Izzy.
You multiply by 2 on both sides.
Right, okay, so you multiply 2 by both sides, okay? And so when you do that, you multiply by 2, but I shouldn't choose white, it won't, wait, we need a new color here. How about a nice orange? Puke green? How about, where's my teal? I like teal. Okay, so you're gonna multiply, is that teal? Tealish?
Kinda like gray blue.
Gray blue, so those cross out. I get minus 2 plus y equals 8. Add 2 to both sides, I get y equals 10. So now I know that the endpoint is 10. The other endpoint over here is 10. And just to check, negative 1 plus 5 makes 4. Divide by 2, I get 2. Negative 2 plus 10 makes 8. Divide by 2, I get 4. So it checks. Okay? So that's all she wrote.
Don't delete this one, too late.
Don't delete this.
No.
Okay, but I am going to stop my video here. I'm going to pause for station identification.
Thanks for watching.
Thanks for watching.
This has been a leader video.
Stop.